show me a
give
single
that
piece
up.
of data.
Just give
Show us
that
a
up.
single piece of data you
Seriously,
posted
I'm
to
gonna
support
ban
any claim
you.
you made.
I mean, you're kind of proving my point if you do that.
Show me a single piece of data you posted to support any claim you've made.
007, you asked me to provide predicting power. I did. That calculator, under certain weather, like weather condition, it can predict at which distances you should be able to see certain objects.
Okay.
Yes.
So someone went out, used the calculator, right? Used the values of the calculator, went out, so they took a bunch of meteorological stations, they stuck them out there, they fed those values off the meteorological stations, rendered an image, and then when they compared it to the real world image, they matched. That's what they did.
No, that's not what they did.
So they made a prediction of what they would see based upon the weather conditions.
No, I told you. I told you
So
that
you don't have a predictive model.
So for the model that I
showed, you can't admit what goddamn they admit in mainstream
science. It is a predictive model.
They admit it in mainstream science that they cannot make predictive model. They can't make a predictive model for refraction. They admit this.
I disagree.
It doesn't matter if you disagree. It's written down.
I mean, if it's written down, it must be true. That was sarcasm.
It's written down by people that have studied this. Okay? There's 150 years of people trying. They even call it an enigma. They call it that.
I mean, do you not accept Snell's law to be predictive?
Snell's law is a special case.
Right?
Homogeneous isotropic mediums with a well-defined boundary.
Yes, I agree. But then you can use calculus.
That is not the error.
Right, but then you can use calculus, where instead of having a single boundary, you have a continuous boundary, meaning you have a continuum of different dielectric constants
but
changing.
Snell's law does not hold. But listen, Snell's law does not hold in a gradient index medium. Does not hold.
Right, because Snell's law is by definition the one that is used in a single boundary. But if you take that and you apply it to a continuum, you get a generalization of Snell's law that you can use to make predictions, right? Like you can take a liquid in a tank, right?
You can predict anything you want. Who cares if you can make a prediction? The thing is, does it match reality?
Yes, it does.
Okay, show us that data.
Example.
For the last freaking time, dude.
Example.
I already did. You're just not accepting it.
We have a prediction. Where is it?
You haven't.
I already showed it to you. I can show it to you again. Do you want me to show it to you again?
What are you showing me? You're showing me a predictive model for refraction in the air.
Absolutely.
That's what you're showing me. Okay.
Yes.
Okay, let's see it.
And the data is the picture that was provided on this very own server, might I add.
Oh my Jesus Christ, dude.
He doesn't get it. You got the ambient conditions to apply to the prediction.
So before the image was taken, there was a prediction made. Then they took the snapshot and compared it to the prediction of the model, and it matched. That's what happened.
I don't know if it was done in that order, right? But
that's what a prediction is. Predictions only happen in one fucking order.
Okay, well, I'm responding
to
this.
Otherwise, it's called a post-diction. And a post-diction is non-scientific.
Okay, excellent. Then let's do this instead. You and I can do this, right? So let's take the calculator, okay? And since it's not changing, I'm assuming that all possible outputs of the calculators are predictions, right? So I can retroactively go and use the calculator.
No.
Why not?
It depends the use, how you use it.
Right. There are basic assumptions that are made in the calculator, and as long as we're using the calculator to measure the effect.
Do you have anything other than refraction, or is that what you're going to come with every time you come here? I'm just.
Are you cutting me short on this?
No, we're not begging
you.
you.
Can you answer the question?
I'm trying to answer the question. It's just difficult when you interrupt.
It's not difficult.
Look, you know you have
yes or no.
You know you have nothing, dude, and you're just like flapping around like a fish out of water at this point. All you have is a post-diction. Listen. At best, you have a post-diction. You don't even really have that. Well, let's call it a post-diction. You don't have a prediction. You have no predictive model. You're just saying the Earth's a globe. We see this. Therefore, there must be some other phenomenon happening because the Earth's a globe.
So let me get this straight.
It's an ad hoc hypothesis.
Let me get this straight. You don't think the calculator is a prediction in and of itself?
Dude, you're trying to deflect and talk about.
I'm not. You're the one saying that it does not hold any predicted power.
The way you use it, it determines whether it's post-diction or prediction. How do you not understand this?
Hey, Charlie.
There's a hypothesis. Listen, Charlie, does the hypothesis come before the experiment or after?
Typically before.
No.
Typically?
No.
In what scenario does it come after?
I can't think of any, but that's why I said typically.
So it's sophistry.
Always. Otherwise, it's not science. You should look at Wikipedia. Ad hoc hypothesis. Why don't you Google it or something? Ad hoc hypothesis.
I mean,
that's what atmospheric refraction is an ad hoc hypothesis. There's the globe, therefore there must be refraction. Okay, demonstrate light bending down in air. Oh, nobody can do that.
We did though.
You did? Show us.
Yeah.
Show us.
I mean,
show us light bending down in air.
It's in the picture. That's what it is.
No. That's just listen. That is not light bending. Why? How do you know the light's bending down in the air? What in that image indicates that light's bending down in the air?
You're right. Excellent question. Because otherwise, it is circular reasoning, isn't it? So the reason that we know that is the case is because we know the laws of refraction, and we can predict
in a constant medium.
Based on
already covered that.
Jesus.
Yeah. The laws of the constant media.
That. All you did was circle around right back to the beginning and make a claim you have no support for. Okay? We know the laws of refraction. The laws of refraction that can't make predictions. Those laws?
The laws of refractions can't make predictions?
They can't make predictions in this case. They cannot make predictions through the regular air. What you call the atmosphere, it cannot be used to make any predictions.
I disagree.
Then show us.
Well, I mean, that's it's
not a refutation.
Right.
Okay, so why don't we start? Excellent. Why don't we start with this? I mean, I don't know if I can do it at home. I'll have to look into if I can do it at home. Why don't I get a tank of air? Yeah?
Mm-hmm.
And then I get a tank of air that is hotter or colder. And see if there is a refractive effect at the junction, yeah? To start.
What type of tank?
And to see
fish tank? A fish tank?
It can be whatever tank you like.
Are you going to shine a light through the tank itself, then through the air? That's two media.
Yeah, but we can concatenate the effect.
No, but what?
But
we can
measure. Snell's law only applies to isotropic constant media, uniform media.
Right, but you can generalize it to a continuum of media.
Yeah, is generalization?
Listen, that is wrong. Okay, I'm sick of you saying that.
It's not wrong.
Okay, I'm going to post a paper. Yeah. Listen, you're just factually wrong, dude. You're factually just wrong. And I'm going to post a paper from a mathematics department that says that you're fucking wrong, dude. You're just wrong.
Okay, go ahead.
Charlie, while he's getting that, I just have a quick question for you. What is your percentage certainty that you live on a spinning ball and that the globe model claimed actually does match reality? What percentage would you say your certainty is?
Higher than 99.9999.
Wow. Percentage.
So you don't really understand. You don't understand the nature of science. Then that's unfortunate, but it's not surprising the way that science has been, portrayed. I mean, you sound like a relatively young person. Like the way science has been portrayed in popular media lately is more just kind of like a sports team. Go science! Like nobody really takes it seriously. To find the spirit of scientific inquiry in any kind of academic institution is like looking for a needle in a haystack. You can find it in an isolated teacher or professor, but it's very rare. So it's unfortunate for me to hear that you do not understand what science actually is. So, hopefully you'll stick around and listen. India's got something there for you in the live stream voice text.
I mean, it's a little hard to stick around if I get deafened every time I'm here.
No, you just wait for people to undeafen you.
So, this shows that if you apply Snell's law in the way that you want to apply it, it's incorrect. Sine theta is not a conserved quantity in a gradient index medium. Yes, I did, in live stream voice text. And there's even a link to the paper itself. You can review their mathematics if you see fit. This is why in what they call geometric optics, where they actually deal with gradient index media, they use the principle of least time. They don't use Snell's law because Snell's law fits error. So, listen, maybe you don't know this, but I'm going to hip you. This is something I studied before I was ever a flat earther. I knew about this a long time ago.
Do you mind if I take a moment to read this?
Yeah, have at it. And I've told Walter Bislin that he's doing it wrong. I've told Nick West his simulator is doing it wrong, that they're just not doing it wrong. And you know why they're doing it like this? Because they have to. Because it's the only way they can get the results they want. Because if they use actual ray tracing, they don't get the result they want. Because light doesn't do that. You can't demonstrate it. It's why you have no experiments. It's why you have no data. It's why you have no predictive model. I mean, it's just like, how high are we going to stack these things, the things that are absent? Just saying, nuh-uh. It's not a refutation, and it's also not an affirmation. Proof by repeated assertion. You can't demonstrate it physically. You can't predict it with the model. Like, what can you do? You can just say, the Earth's a globe, therefore, it must be that. But, application in the real world, like, why aren't standing armies hiding on the side of another frickin' hill instantly seen, and then they can't do a sneak attack because now you see all their heads because they were refracted up over the hill? Like, why aren't they aiming to hit boats and they're aiming up because, where they actually appear to be is not where they actually are? None of this stuff is applied in the real world. This is a fantasy. You literally just have a fantasy.
And then coming here with some kind of air around you, right? It's just he's deafened. Okay. Well, he came in.
Yeah, maybe he's actually reading the thing. Let's hope.
So he came in.
You think it's going to change his mind?
No,
of course not.
Of course not. This is religion.
It would have to be on CNN for him to change his mind.
Yeah, so he came in, and then the first thing he said was, I learned that some flat earthers, you can't talk to them because you just rather deny everything, yada, yada, yada. Right?
Look, all I'm asking for is I want affirmative evidence for his claims, right? Just like you're making a claim, we want the affirmative evidence, something to support it. The substance, right? The substance. We want the meat and potatoes. Where's the meat and potatoes? There isn't any. We're starving over here. Want some substance?
That's right.
They claim that deny everything, and that's exactly what they do. They have got no evidence whatsoever, and they just go, like you said. Oh, yes, it is. Oh, it's a globe, and they got no evidence. And you would think that after a while they would think about it and go, you know what? Maybe we are wrong about this, because they are. But they don't ever think that way. It's ridiculous.
Yeah, people, like some of the pioneers of real scientific inquiry, can you imagine if they have people, this is the best the globe's got to offer, is this guy that comes on here and says, oh yes, the model, it's definitely 99.99% accurate, even though there's thousands and thousands of data points, questioning it, even though they can't come up with scientific evidence for curvature rotation to save their lives. This is the best you guys got. This guy is a perfect demonstration of why the globe is a religion. He just believes in it, and he's so sure he's right. It's a religious belief. He came right out and told me he didn't have any scientific evidence of curvature or rotation. All he has is obfuscation, going into showing how he went to middle school science class, so he knows about significant figures, he knows about precision and measurements, he knows all that stuff. He read the glossary in his middle school science book, guys, and somehow we're supposed to think that, and it works. Because he's a slick talker, a lot of people would be fooled by him if he wasn't up against, you guys in here that aren't going to let him get away with this nonsense. So I'm glad he at least stuck around for a little while. We'll see if he has the guts to undeafen himself ever.
He's more fascinated, more busy with people than the actual evidence, right? He came in talking about chemo, then he talked about Witsit, about people not listening to him and deafening him, right? It's all about the people and not about the evidence.
Oh, yeah. How many times? Yeah, if anybody was bored, they could go back and count how many times he complained about being interrupted and muted. And then I want you to take your stopwatch like I did and measure how much time this guy's been talking. He's been talking a ton since I got here, way more than anybody else. And then he's on there telling us we're not letting him talk. Yeah, you've been talking and talking. You just don't have any evidence. You just got nonsense. He's got nothing. And that's why this kind of cult personality that believe in, the science of it all. I believe in science. I'm going to put a rainbow poster in my yard that says that. They are all, because they think we're like them. They think, oh yeah, you got Witsit's your leader, Chemo's your leader, whoever, Quantum Eraser's your leader, like you are all the same and you follow them. It's like, no, we don't. All those people could retire tomorrow, which would be sad. We would miss them. They are great voices in the flat earth community, but that doesn't change the measurements and the observations of this earth where we are, that any person, anyone in here, anyone in the whole world can, with a tiny bit of effort, not very much money, go out and see if the predicted curvature matches reality and find out that it doesn't. We don't need anybody on TV or on YouTube to tell us that. But they don't like that because that's how they get their information, because they don't have reality. They don't even live on this earth. They live in some kind of fantasy computer generated reality, and they want to stay there. And like I told the guy, stay there then. I don't want to live there. I'm glad I'm not that guy. Gosh.
This is what he did last time when people didn't accept his ideal refraction formula. It's the exact same stuff. That's why I called him Rerun.
Wasn't Rerun a character? What was that? Was that on What's Happening or Fat Albert? Who was
Good
Rerun?
Times.
But it's
Good Times. Like, I get those they all merged together in my mind. Good Times. I haven't seen that in a long time.
I don't think it was.
I don't know.
Yeah, it's tactics, right? They only have tactics. They learn it from where he's probably.
It was what
mostly
happening.
Right.
Rerun was the fat guy on What's Happening. Sorry, Roger.
Yep.
Thank you. That was important to mention. Thank you. Thank you.
More important than
the
Charlie.
Fat guy on What's Happening, right? Yes, he was very funny. Yeah, I remember that guy.
Exact same set.
Who did the hey, hey, hey? Was that Gadrakin?
Yeah, it was.
That was good. That was a good one.
Put the comparison in there with this dumb Glober comparing him to Fat Albert.
Are you 007? Are you here?
Hey.
I guess he's not.
That's
Well,
Indio,
he's
right?
probably he won't be far. Indio reruns back. Did you read the article? Is that what's happening?
Yep, I have read enough to know that I am incorrect.
Sorry?
He said he was incorrect.
I said I've read enough to know that I am incorrect. You cannot, in fact, take Snell's law and generalize it using calculus. You can get an answer, but it is not as correct as other.
It won't even be an approximation.
Apartment's right by Days Inn, so just go.
It is an approximation. It's a shitty approximation.
No, it's not. That's why they use the word generalization, because it's not even in a category of an approximation. It's not approximate at all.
I guess that depends on your definition of approximate.
No, it's a category area. Define approximate. Almost correct. It's not. It's not even close.
I disagree.
And then going into word games again, right? Arguing about words, Rerun.
Oh, you guys changed my name again. I
It's called a generalization because you get a general ideal, not an approximate ideal.
Why don't you change my name to something funnier or original?
There's a reason people use words, since how the English language is clearly defined so you can use coherent and cohesive sentences.
Yeah, the problem is that for some reason, people still fall into semantic arguments as evidenced here.
Oh, they do. You want to call a generalization an approximation, and that's a category error. Sorry, but it's true.
Even though it's true, Baramor, he disagrees.
Yeah, that's a general statement.
Generic. It's all generic coming from the Globers. One thing after another. Same generic.
That's
bullshit.
right, Yes, Lunatic says we only pick on the ones we like. You are entertaining. I do give you that, even though Battlemat thinks you're a rerun. I mean, at least, sometimes in the summer, that's all you got is reruns, right? So we accept it. But Indio did say, in case you missed it, Charlie, that he, in about 10 minutes, he'll be able to speak. He's in a noisy place, so he probably would like to hear what you think about that article.
No, I mean, he changed my mind. He changed my mind about Snell's law being able to be applied to continuous materials.
Welcome to Flat Earth, then.
Well, that's a massive fucking leap.
It's going to take him a while to get from that 99.99999. How many nines are after that decimal point, Charlie?
Oh, you guys haven't even made a dent.
Oh my gosh. Is there a Google of nines?
It's changed. Now it's like 91.9999999%.
That's all right. I'm not here to convince anybody. I just asked...
yeah.
Well, I guess you guys can try to convince me if you want.
Oh, that's a good thing, because you haven't convinced anyone, so...
I'm not trying to.
Failure.
I'm not interested in doing that.
Yeah, so you're not trying to convince anybody, but you wanted to talk about convincing Chemo, right?
No. So the only reason why him and I went at it was
that's.
Do you want me to answer your question?
No.
Okay.
I just wanted to point out. I just wanted to point out your contradiction, right? I'm not here to convince, but talking about convincing others.
Well, why did you come here then, Charlie? What was your motivation?
I find people on here extremely interesting.
So do I. Look at that. We got one thing in common. I think that's the first thing we found.
Yeah, we are as guinea pigs. Is that it, right? Space Cowboy fanboy. Are we your guinea pigs? We need to practice a game, or is that it?
That's what I'm thinking. He could be practicing, and I'm sure, like in other crowds, like this routine would work for sure. I mean,
are you asking me?
I mean, I'll acknowledge you got a good sophistry, observation routine going on.
I'm gonna be honest with you guys, as I have been honest with you guys, but I ask that you don't feel insulted by what I'm about to say, or if you do, I guess you could mute me and whatever. I find what in my view is people who have an incorrect view about something that's very basic about reality. I find that to be by itself not interesting, because there are things which I have been wrong about. I'm wrong about a lot of things all the time, right? So that in and of itself isn't what's interesting to me. What's interesting to me is that typically when I have an opinion about a subject, I am aware of my lack of understanding of that subject, and therefore I don't go around making assertive claims about it. What I find super fascinating about this group is the combination of what I perceive to be ignorance, but also arrogance about this subject.
Ignorance, huh? What's your academic level?
I have a master's in computer science and engineering.
Sure. You don't sound old enough to have a bachelor's.
I'm 29.
Well, then I'm about right, aren't I?
You think 29-year-olds don't have bachelor's degrees?
Not a lot of them. Some may.
How old do you think you typically are supposed to be for a bachelor's degree?
Well, it depends on if you go to college straight out of high school.
Yeah.
Or if you take a year off.
Wait.
Okay, let's say you take a year off.
I wanted to go back to what he was talking about. You guys talking about it, but I totally forgot what it was. But what you just accused us of is you. I mean, I just don't know if you realize. Like, I would go back and rewind that and say, if you are a person who in any way, is interested in self-reflection, rewind, 20 minutes after the hour on the live stream and think, and ask yourself, I'm not asking you to do it for us, but, if you're interested in personal growth, intellectual growth, and so on, rewind that and say it honestly to yourself, not to tell anyone else, is there any part of that applies to me?
Dandelion, I don't presume to be exempt from that.
Say it to the man in the mirror. I
don't presume to be. Everything that I accuse people of, I never assume, oh, I'm not like that. Never ever do I do that.
I'm not perfect.
Honestly,
you are like.
Honestly,
because you just said
it terrifies
you're sure
me.
that we're wrong. Okay, Space Cowboy, what makes you sure that we're wrong
Charlie,
about
please.
reality? Tell me, Charlie, I'm sorry, I called you Space Cowboy. I can change it to something else if you want. Anyway, I changed your name. I didn't do the first one.
I mean, how about you give me a funny role, but change my name back to Charlie, just so that because it causes confusion.
I've given you so many funny roles. Have you not checked your roles lately?
Oh, I haven't.
Not just me. Oh, yes, other people have been giving me. I only gave you 3.
Okay, that's fine. You can add as many as you like, but look, the only reason why I asked my name to be changed back is because it causes confusion. That's it. Because sometimes people are like,
I know.
Oh, elf with a huge penis. What do you think about this? And I'm just clueless because I don't know that they're talking about me.
I know, because you don't know it changed. I understand. I'll change it back to Charlie if you answer my question honestly, which now I can't remember what it was. Does anyone remember what it was?
You asked me what makes me think that I'm so sure.
Oh, what makes you so sure that we are wrong about reality? Because that was your claim, was that you like to hang around with people who it's not interesting for you if they're wrong about reality. No, this is a key Glober psychology.
Ignorance and arrogance.
You right back. They get really upset when we're certain, and we're certain because we've done the measurements, because we've done the work ourselves. Because we've tested this model in the real world, which you have not done. So that's where you call it arrogance. I just call it certainty, because we're not attached to that model. It's not meaningful to us. We're not invested in it. I mean, some of us have careers where that's kind of pushed, because it's pushed everywhere. I mean, pretty much all of us, if you don't have a career where it's pushed in some way that you can't necessarily go out there and shout it from the rooftops. Some of our friends do, like you, apparently you're familiar with Witsit and so on, which is perfectly fine. But, we aren't invested in it personally. We were at one time, like years ago when you first start to realize, oh boy, like, when I first started doing my research, which was for a term paper when I was getting my master's, that's why I started researching Flat Earth, Charlie, is because I wanted to be just like you. And I wanted to show those students, but a job of it. I wanted to show them, that was the assignment, write a term paper of how you would show students their misconceptions about the flat earth, because that was popular at that time in 2016. The tequila, whatever, B.O.B., all these, pop culture people were on Twitter saying the earth is flat. So that's going to be just like you, Charlie. Difference between me and you is I actually allowed myself to try to be objective and investigate, is there anything to this claim? So I ended up where I am today. So that is what you call arrogance. I call confidence. It's something that you have when you're not living in the point of cognitive dissonance, where you have to try to defend something that's not even your thing. You didn't research this globe model and make it up and tell everyone this is how it works. You can't even tell what the best evidence is. Should be at the top of your head if you're so sure. 99.99999. But you can't give me one piece of proof. It should be very easy for you to prove the globe to me. You haven't done it yet. So
I provided the evidence.
I'll change your name back to Charlie. Okay, if you provided it, it should be easy for you to just on the top of your head, just.
Oh, you did not.
3 proofs. Best 3 proofs. He said he already did it. So repeat it.
I provided the evidences, but you just don't accept them. Anyway, I have one question. Can you change my name to a Y? No, Charlie with a Y, the Space Cowboy?
No.
Charlie, the Space Cowboy with a Y? Oh, come on.
No.
Somebody else.
It's with a Y, not with an I.
Charlie,
how about I just take away your name altogether?
That's the best. Yeah, I'll change it to a Y if you give me your top 3. If you're a person who has a master's degree, you should have learned how to put your thoughts more concisely. You should be able to give me 1, 2, 3 points. Best proof of the globe in 30 seconds. Go.
So the strongest evidence for the Earth being a globe for me are the hours and hours and hours of 4K footage that we have from space of the planet. Number 2, I would have to say. Off the top of my head, I don't actually know if this is number 2, but this is just what's coming to mind. Is the experiment it's not an actual scientific experiment. It was just sort of like a backyard experiment for the amateurs collaboratively did, where they measure the angle of the sun on the Earth, right? And then finally, fuck. What was the Greek experiment?
3 seconds. Greek experiment. That's your number 3. Got it. Okay, I'm gonna put this in.
Aristophanes.
Aristophanes.
It wasn't an experiment.
Oh, come on. Change my name to Charlie with a Y. You can be Charlie the Space Cowboy. That's
you
fine.
answered me. I am going to do that. Yep, just a minute.
I'm
putting your 3 points there in the voice text so we keep track of them. I'll even tag you. So if anyone tells you didn't do it, you can say, I actually did do it. Here we go. So number 1, hours and hours of 4K footage of globe. 2, measurements of the angle of sun on the Earth. And 3, Aristophanes. Does that sound about right? Is that what you said?
Yeah, I mean, I have more evidences for it. I can go and name them.
Not one of them are evidence. Any one of us can walk you through how they are not.
I mean, So I agree that certain evidences are shitty and certain evidences are good, but they are
evidences.
So
you can't even make a logical inference from TV. You can't verify anything you see on the boob tube. The Sticks takes too many assumptions. He couldn't accurately measure a stadia. The guy couldn't tell time accurately. He didn't know where high noon was. He made the mistake of believing Alexander and Cyrene were on the same longitude and latitude. They're not. We know they're not. And then he assumed that the shadow, if all those other assumptions were true, the shadow the angle of it would be equal to 1/50th of the radius of a sphere. If Earth was a sphere, light was parallel, and he could accurately measure all that shit. But he couldn't do any of it.
I'm okay with you taking that interpretation from it. I'm not trying to convince you, as I said.
It's not an interpretation. I'm critiquing it.
Okay.
And I'm not the only one who critiques it.
And
most of the intelligent world knows that he made too many assumptions, and we obviously, how do you think we figured out quite a few of them were wrong? People critiqued it.
All of that also is if the guy even really existed, there's a good chance that he's just a myth. Was it Wells or was it Sticks and Shadows? I mean, who is this freaking guy? Like,
so I have a question.
So how are we ignorant, Charlie? How? We just explained the whole story to you. How is it that we are ignorant then?
Can I ask my question before I answer that one?
Well, you
or how about
ignorant?
No, just go ahead. Don't make it long and dried out, Charlie. Just ask it.
Okay, so my question is, so you guys believe in planets, right? And when you look at planets up with a telescope...
Did we say that?
You don't believe in planets?
And you're going to say you see a sphere when you look through a monoscopic view. Denying that the fact that you need a stereoscopic view to see in 3 dimensions.
I mean, when you play a video game that's in 3D, you're seeing it through a
You're
flat
using
monitor.
2 eyes. When you look through a monoscope, telescope, monocular view, you're not using 2 eyes. You don't have 3 dimensions. You can't judge depth.
Right, but your TV screen is 2-dimensional. And just because you're seeing it with 2 eyes, you're just seeing the same image twice, right?
The projection isn't.
If I get 2 telescopes, would that change your mind and I put them side by side so you can put 1 eye in each?
What type of telescope do you own, Charlie?
I actually don't have any telescopes myself.
I mean, you act like we can get an amateur telescope and we can see what they show us, the images.
My father-in-law has a telescope.
I'll tell you. Listen, I live in the country. I probably got 15 grand in telescopes right now. I've been watching stars since I was a Cub Scout. I've never seen a rotating ball in the sky through a telescope. My Orion Galaxy Quest 10-inch reflector, man, it's like $9,000. And it still isn't that much better of a view than the one that only cost $1,500.
So
you don't see the images NASA shows you.
I had a specific question about, in particular, Saturn, but I guess it applies to all the other planets. So why is it a problem that what you see in your cheap backyard telescope is not what NASA's super expensive telescope shows?
Well, here's the problem. You tell us we see balls in the sky, right? And we live on a ball, and we're looking for the evidence right here on Earth of the similarity between what we see in the sky and what we live on. God's capable. But there's no similarities. For us to say we see a bunch of circles in the sky, we should live on a circle. We should see evidence that we live on a damn sphere. Like
I agree. It's not a good. I agree that we see balls in the sky, therefore we must be in a ball. Is not an ironclad argument.
We don't see balls in the sky.
No, it's not.
We don't see balls in the sky.
Okay, wait. You don't see balls in the sky? What are you talking about?
No.
We just covered the 3D view. Go get you a good telescope and take a look for yourself, Charlie. My kid was mad at me when I made him look through my best one, because none of them, not even Venus on its closest path, look like any image NASA ever gives you.
Okay, that's fine. Can we talk about Saturn? I mean, Rodwen, you just took a picture of Saturn. Okay, so what do you think that is then? If it's not a sphere with a ring clearly going behind it,
it always looks exactly the same.
Right.
Yeah, I'd like to see the image. I'd like to see the image you're talking about. I don't like to make statements on stuff I'm ignorant to.
Yeah, Charlie is trying to beg the question.
So let's see the image
behind.
So you're right. It could be circles. The Martoth, the one you posted. It could be circles or it could be spheres, right? But the reason I bring up Saturn,
this is
in particular, is because it allegedly has a ring going behind it, right?
Yeah, that's what you're begging the question that it's going behind it, right?
That
You're
picture right there I posted.
You're assuming it. There's no way you can ever prove this, Charlie. So, okay, we're not going with your narrative.
Yeah,
I'm not making a claim.
Can I ask you a question? Why is it you go to the sky to prove the shape of what you live on? Through assertion.
I don't.
Inference. Everything you do is about the heavenly bodies that we see above.
So
somehow they prove a sphere.
So you think that video from the sky?
Don't put words in my mouth.
I'm asking you. I'm asking you if you're inferring that. If you're implying that.
Inferring what?
I'm asking you if you're implying that video from space counts into that.
It does. Can we verify, test, or repeat video from space? Is it an empirical scientific evidence?
Yes, it is.
That's the question. No, it's not, because we can't repeat it, we can't test it, and we can't experiment on it.
Yeah, we can repeat it.
Okay, go to space and repeat it for me then.
Well, I don't have the money for it.
Well, there you go.
As a society can. And we have.
No, listen, there is no we. We're all individuals. The average man cannot question anything they say. It's unfalsifiable to us.
Right.
So therefore, it's not science.
But the fact that the average man can't afford to put a rocket in space doesn't mean there isn't space.
Listen, Elon Musk can't even give the proof to make it 100% absolution.
What would that look like for you?
It'd show the entire fucking trip. There wouldn't be no cutoff.
I guarantee you that when the moment comes where they actually show footage, uninterrupted 4K footage from the Earth.
Don't make checks with your mouth. Your ass can't cash.
You will find an excuse. You will find a way out.
You're a true believer. You're the religious believer here, Charlie. So just let it be known, August 5th, 2021, maybe sometime in the future, not going to be anytime soon, maybe 10, 20 years down the line, you'll think, gosh, I was the religious believer back then on August 5th, 2021.
He's got faith.
I know you can't see it now. He's got faith. I know he believes in these guys. Yeah. And he doesn't even see how it's not science. He doesn't get it. He doesn't get it.
Someday you'll see. We'll show you and you'll be judged for your sins, you unrighteous man. NASA's right. They said so.
Oh, I don't believe you.
That's right. That's what he just said. It's like, one day you'll go to heaven and you'll see when you're on Mars. It's so funny. I mean, it's just hilarious. He's like a parody of himself. I'm sorry. I won't go on. I'm trying to be nice to you, Charlie. I'm doing my best.
No, that's okay. I was.
How do you have gas pressure? How do you have gas pressure without a container there, Charlie?
Oh God, we're moving on to that.
How can the? Yeah, let's do it. Why not? New topic. How can the medium outer space even exist in the way claimed?
Okay, so. What is a container, right? You have to ask yourself for that. What does that container effectively do?
A physical barrier that contains things.
Well, it depends what you mean by physical barrier that contains things, right?
No, physical is well defined and used in proper context.
As everyday, you're correct. But in terms of physics, it has a more sinister definition than that.
Well, gas pressure is force over surface area. The walls of your container.
I mean, are you going to let me speak?
You get surface area from a non-existent, non-physical wall?
Battlemod, can I please speak uninterrupted?
Yes or no? Yes or no?
Can I please speak uninterrupted? Because you're just fucking bullhorning the conversation.
We went through this one once before now, didn't we, Charlie?
I mean, again, I'm not trying to convince you of anything. I'm not trying to convince anybody here. You guys are asking me what I think, and I'm trying to tell you what I think. And so don't fucking come at me after you ask me to tell you what I think.
Listen,
I asked you. I'll give you a minute.
Calm down,
Start
kid. Cool your nuts. Put them in an ice water or something. Don't be cursing me out. Cool?
Absolutely, I agree.
I haven't started cursing you.
Okay.
Tell
fine.
us how you can have gas
I
pressure without a container. How does the fantasy medium outer space exist? Go.
Okay. So what a container is a force on molecules. Ultimately, what a container, like if I take a water bottle, okay, and I put water in it, what is keeping the water molecules from leaving the container? Okay. Well, the container, in this case, glass, my piece of glass here, it's a lattice, right? Meaning there are molecules of silica arranged in a solid way. And when the molecule of water gets close enough to it, there is a repellent force that keeps it from going through. And that force is mostly electromagnetic. Okay? Like, it's electromagnetism that keeps things from going through each other. Some people argue that it's quantum mechanics. I tend to not think so, but whatever. So, ultimately, it's just a force that's pushing the molecules back. That also happens over greater distances when you look at the Earth as a sphere. So there is gravity, which acts over a distance, over a less distance, right? So the air in the atmosphere just tends to go down via that force. So you can think of what the container is to be the gravity. Because a container, all it really provides is a force to keep a fluid in.
Okay, we got a minute and 20 seconds of
you know what? It's called container theory. It's metaphysics.
You have to demonstrate, how this force, this force is going to do that.
Yeah, that's what I was going to say. You can't demonstrate that. You have no cause and effect relationship. Experiment to prove gravity, and we don't even know which gravity you're invoking, Einsteinian or Newtonian.
Einsteinian, although one is a.
So the warping of space-time due to matter can attract the matter of the gas. Can you define matter?
I mean, again, I'm not trying to argue with you here. You guys are asking me what I think about this, and I'm just telling you.
I know.
If you want me to elaborate, I can.
Just about it. It's metaphysics. You do know what metaphysics is, right? It's a theory. And it's not even a scientific theory because you can't demonstrate it. It's not backed by experimentation.
Hold on. You think that general relativity cannot be backed up by experimentation? Is that what you just said?
Or I'm talking about container theory. The container theory of space. It's metaphysics. And it isn't backed by any experimentation. Neither is special relativity.
Well, I disagree with you, but that's okay.
Show me the warp in this space-time.
Sure. So if you look at
demonstration, please.
For sure. So for example, general relativity can predict the precession of the orbit of Mercury.
That's not what I said. We can predict the precession of that. Yeah. It's a post-diction because we watched it for thousands of fucking years.
Okay, there are other predictions that it makes and that we see, right? So the shift in, for example, background stars near the sun, that is a prediction that general relativity made. It took years to verify that. That is an actual prediction that was made.
It's not a verification. It's a theory. You can't demonstrate it. I asked for a simple demonstration.
You're right. I don't think the average person can demonstrate.
I don't think anybody can.
I disagree.
The only thing you can do is point at the sky and say that light should be behind that other light, but we see it and it's this way because I assert it. You can't demonstrate it.
No, okay,
just like you can't demonstrate gas pressure without a container. You can assert that the air on Earth is uncontained, and you could say the atmosphere, but you can't demonstrate it. You can't prove it.
Battlemon, if two stars are always the same distance apart when we look at them at the sky, except I haven't even finished.
I know, but it's a theory.
Okay.
Yeah, you can't demonstrate that. We can't set it up in an experiment and come up with an dependent variable and manipulate any of the variables. We can't science that.
You can actually, just because you don't understand it.
No, you can't. There'd be metaphysics, dude. All of that shit in the sky is philosophy. It's just you need to accept it. I know what it is. Yeah.
I mean, that's
if you
okay.
want to go down
I'm not going to convince you.
If you want to go
I'm not going to convince
observation rabbit hole, man, let's do that.
Oh wait, 007, you're here.
That's a good joke, man.
Indio, I have something to tell you. You're correct. You can't just take Snell's law, apply calculus, and apply it to a continuous medium. It doesn't work.
Yeah.
You have changed my mind on that.
Okay. So go DM Bislin and tell him. And Mick West. Because I know both how they do their little calculation for refractions. Other than, like, it has serious problems. I mean, outside, even if what I posted wasn't true, the way they're doing it has just problems, man. Mick West is specifically garbage. Bislin uses a different method, which is, actually Bislin came up with his own little method. But I mean, whatever. I mean, that's neither here nor there. I mean, I posted a bunch of shit on refraction when I couldn't talk. Published papers, right, of them saying it remains a puzzle, an enigma. We can't make predictions. Like, we don't know what's going on. Plenty of papers when they've gone out and tested it. They've tried to make models, so I can give you citations to that, where they actually went out. The Geodetic Survey went out. Other surveyors in Greece went out. They did 2-frequency LiDAR and tried to test and measure the displacement of objects, and make models from the data. It can't be done.
But my understanding of the difficulty is that there are just so many things to keep track of. Right, like the variance in the indices of refraction, for example, is so wild in an atmosphere, right? Because you have areas where it's denser, areas where it's not, areas that are composed of different gases, different temperatures. It's just difficult to track. But the fundamentals, to my understanding, are perfectly described by QED. QED is the best theory that we have for it, quantum electrodynamics. But it's just too complicated. The limitation is practical, not theoretical.
The limitation is practical, not theoretical. That remains to be seen.
Is that a
if you can't test it, listen. Yeah, so the definition of pseudoscience is claims that cannot be falsified by experiment. So if you're sitting here making claims that my model, we have a model out there and it predicts we're going to see X, Y, Z, but you can't actually go test this in the real world, then it's just a pseudoscientific claim.
I disagree.
That's all there is to it. You can disagree all you want. That's the definition of pseudoscience. Coined by Karl Popper freaking 100 years ago.
I mean, you understand that definitions fluctuate, right? And that they're constructs. Some more correct.
I mean, this is even on Wikipedia, so this is still the modern definition of pseudoscience.
And you
claims or theories that cannot be falsified by experiment. If you can't do the experiment, is this science? Can you do science without experiment?
I mean, it's sort of implied there that these experiments are not testable in theory, not in practice. There's a difference, right? Like, if I ask, is it possible to have 10 billion cars on planet Earth? Just because we don't have 10 billion cars on planet Earth doesn't mean that it's not possible to do it. We can't test it, right? Because it's just not practically feasible. But there's no theoretical limit as to why we can't do it.
Okay, but we're talking about science, right? Is 10 billion cars on Earth a scientific claim?
Sure. Why not?
So science is supposed to be empirical and
well, I'm trying to demonstrate to you that
to just imagine things.
I'm trying to demonstrate to you that something can be practically impossible, but theoretically possible.
But that's not my problem. That's your problem.
This is not the theoretical server.
This isn't my problem. You're claiming objective truth, and I'm not. You're claiming this is objective truth, that this happens, and you're basing your existential reality on it. I'm not.
It depends what you mean by objective truth, right? I've admitted that I'm not 100% sure of this. So to me, objectivity is up to a degree. It's not 100% certain. When I say something is objectively true, I mean I'm 99.9999% that is certain. I'm not 100%
based on no information. Great, thank you.
If we can't do the experiment, what's the difference between that and faith?
I'm just wondering
what's the difference between the claim and faith? I mean, like,
we can't do it in practice or in theory.
What do you mean in theory? Listen, what is theory? Is theory real world? Is that imagination?
It's real world. Like I can't in practice build a rocket and go to space because I don't have the resources to do it. But there's nothing that is physically preventing me from doing so.
Yeah, it is. The second law of thermodynamics is preventing you.
Fucking funny. Oh, that's pretty funny. Listen. You're trying to use like a personal anecdote. We're talking about a general in the general case. Okay.
Right.
So
I'm trying to use a personal anecdote to explain to you.
I can theoretically think that I can jump over the Empire State Building. And practically I can't do it, but theoretically in my mind I can.
No, you can't in theory do it. You have a limit as to how much energy you can get out of the muscles in your body. Right? And the energy required is far less than the energy required to beat the height of the Empire State Building. See, this is what I mean.
What you did earlier, you could just appeal to the future. Maybe in the future they'll have enough energy.
What?
Maybe we'll come up with a certain type of steroids or some synthetic type of ATP where we can actually exert more energy out of our muscles and jump over the Empire State Building. But because I can't practically do the test now because this synthetic form of ATP has not been invented, doesn't mean I can't theoretically do it in the future. This is you, man.
That is not what I mean when I say in theory.
Oh my God.
Listen, a theory is a mental construct. They don't exist in the physical world.
I disagree.
Just because you construct something in your mind, okay, give me a jar of theory.
Many things are in theory possible that are also practically possible.
Welcome to the Glover Twilight Zone.
You really think theories are physical?
They can be.
Once again,
I'm not talking about theories. I'm talking about when, like, what I mean when people say, "Oh, X is possible in theory, but it's not possible in practice." That means something. That has an actual meaning, right? And I don't think it's very clear what that meaning is.
Have you guys found a claim yet?
Again, I'm not trying to convince anybody here.
Well, I think you're trying to convince yourself, actually, which I don't think you are.
I think you're right about that, EXO.
Point out real quick, you didn't answer Roger's question from 20 minutes ago. Like, why are we ignorant? Why do you think we're ignorant?
Yeah, I mean, I think that's self-apparent, but I can restate it. So the reason why I think that you're ignorant is because the notion that the Earth is flat is an archaic, debunked notion.
Spoken right off Wikipedia. Unbelievable. What a fucking robot. Unbelievable.
I
Mm-hmm.
know, isn't that funny? That's like what you see on the YouTube videos, too. It's like, oh, I think you're ignorant because I can recite something that's been thrown in front of my face 500 times in the last year. I know how to recite passages from Wikipedia. That's why you're ignorant. Is that your best evidence for our ignorance?
Wait, that's in Wikipedia?
Archaic perception.
Dude, underneath every single Flat Earth YouTube video, if you mention Flat Earth in any video on YouTube, you'll get a little banner on the bottom that says, it's a debunk thing from Wikipedia. That says,
so I can't use the word debunked?
Yeah, bullshit.
I mean, okay, fuck it. Even if I was reciting it from there, I share that opinion
the
anyway.
globe Earth is what's been debunked, my brother.
Well, that's the point. Is that you're saying the whole world depends on an archaic idea. The entire world experiences a flat stationary plane, so the whole world experiences this archaic idea.
What?
Yes.
Everybody on Earth experiences. Everybody on Earth right now.
Yeah.
Is only experiencing a flat and stationary Earth, I guess,
Right. Right,
You're
watch
just
this,
here
Sonny.
denying all reality on all your senses.
Charlie,
and
watch this,
everything.
Charlie. Watch. You'll admit right now that you don't know where you can experience the Earth curvature. You can't tell me when I can begin to see it.
So, what theory on shape is an archaic? Aristoteles?
Bro, you asked
That
me a
one's
question
not
why I
archaic.
think
No,
you're
that's not.
ignorant, and I did.
Oh my
Your
God.
number 2 and 3 best proofs of the
Archaic?
platter of the globe
How
are
about the-
archaic. Guess
Yeah,
that
what
makes you
about
ignorant
Aristotle?
there, Charlie.
Yeah. How about the Copernican principle? Is that
What about
archaic?
that? Yeah, what about that?
Don't recall what that is. What is that?
Oh my gosh. Why is
Welcome to
this
flat
number
Earth.
still here?
You don't know what the Copernican principle is? Come on.
I'm sorry, my memory isn't perfect. I apologize.
He thinks he has to remember back to 1500.
Listen, guy. All I got is a bachelor's, but I have a photographic memory. You got a master's and you can't memorize and repeat shit?
I highly doubt that.
It must have been my military service that put me ahead of you then.
Yeah, Charlie's never been in the military. Have you, Charlie?
You're just book smart. You don't know anything about application.
I'm an engineer, so you're wrong about that.
Well, if it's true, we share that in common. So cool. You're a computer engineer. There's a difference. I'm
What type
mechanical.
of- You're a mechanical engineer.
Yes.
Really?
So listen, Charlie.
Hold on. We're a
we went
mechanical
through this
engineer?
before. Let's
Hold on.
let's
get into this.
not-
Great. You're a
not
mechanical
sword
engineer?
fight.
My best friend is also a mechanical engineer, and he shares a ton of stuff with me.
Cool.
Can you tell me what a stress tensor is?
Yes, but do I need to? No,
Yes.
because I said we're not. Listen, we're not going to wave dicks.
You're
I didn't
already
need-
waving dicks when you brought up credentials.
I'm not.
Okay, all I'm doing is doing the same thing to you. What is a tensor?
That's what Charlie's all about. Anyway.
You
I didn't wave my diploma until you did. Okay, so let's go.
Who cares about your
said I'm in
diploma?
here.
That's exactly what Charlie wants. To wave around
I know.
papers in the air.
He's the one who did it. What the fuck are you talking about?
Oh man. You provided no proof, and you claim to us that nothing's objectively true, and you're 99% of something that cannot be apparent, is not observed, not measured, or
Charlie,
in any way.
No, hold on. He laughed at me and was like, "What is your highest degree of education?" And I just told him.
Stop it. Stop it.
I am doing the same thing he did to me.
We got it.
No,
Yes,
actually, I didn't ask you any questions about your career. I just left it as it was.
No, you're right, and I'm doing that because
now
that
you
is what
want
you're
me to
doing.
give.
So, Charlie, in reality, when can you experience the curvature? Charlie, do you know anybody, Charlie, who can tell you how high you have to go to see the curvature of the Earth?
What do you mean by experience it? Like feel it?
Oh my goodness! Wow, that's amazing. I said, see, how high do I have to go to begin to see the curvature of the Earth on your fantasy model or in reality?
I mean, with the naked eye, it's you can see it.
Still guessing. Yeah, you're guessing. Right in your imagination right now, you can't even find an answer, Charlie. Isn't that amazing?
There is nothing wrong with suspending judgment. Let me think about
This
this.
is amazing. I love these people.
I think it's funny you're going to critique my profession by vector, but hey.
So you can see it
You don't have a, Charlie, you don't have a claim. You don't have a claim, Charlie.
So
he does.
you don't have
Everything
a
he says is implicit. Let's read again. Let's go back to his quote. Let's look up the definition.
to me, the favorite.
Watch, Sonny. He's gonna tell a lie now. When can we see the curvature of the Earth again?
To me, the favorite evidence for it is the
There we have it. Thanks for your answer. Okay. Wrong again. Glover's wrong
You don't even
again.
have a start page. You don't even have a claim, bruh. That's how easy this is. No claim.
Yeah, I mean, because
we are. We're archaic, and you don't even
the
have
favorite
a claim.
one for me is the Rocket Man 4K video where you could see it for hours and hours and hours, just like
So zero.
cruise
Still
away
no
from it.
claim. Still no claim. I'm looking for an altitude. How high do I have to go? You still
Where's
don't
the
have a
claim?
claim.
Where is it? How high?
You're archaic, Sonny. He doesn't even have a claim, but you're archaic. Thanks, guys.
No, I'm not. I don't think he's archaic. I think he has an archaic belief, but I don't think he is archaic.
That's funny because you're the one talking about beliefs. I didn't talk about. I'm not talking about beliefs.
How are
You're
you
in the
going
wrong
to feel when
server.
how are you going to feel when your belief becomes archaic, Charlie? How would you feel if
I'm okay with that.
20 years from Oh, okay, cool. Well, you don't seem like you do not seem open-minded
I have
at
had
all. You do
I have
not
had
seem to be able to step outside of the model and even consider that it's wrong. When that is the hallmark of a mathematical or scientific model. It's supposed to predict or answer questions about reality. When it fails to do that, you discard the model and create a new one. However, this model is being clung to despite all evidence to the contrary in a completely illogical way. It should have been discarded long ago, error upon error upon error, based on this alleged radius of 3,959 miles. How do you think they originally got that number, which they based all of this mathematics on? I would challenge you to read the book, what's that one, King's Dethroned. Read that book and come back and tell us what you think about that, since you're so into math. I'll find a link for you that you can either listen to the audiobook for free or read the PDF for you for free. But anyway, how do you think they got that radius value?
By basic trigonometry. Anyway, so BattleMod, you just
hold on. How would they do that?
I don't recall off the top of my head. Do I really need to memorize everything, all that's always happened, to be able to
I love how you
answer everything within a couple of seconds? I'm not superhuman, okay? And to answer your first question before you asked 3, I do not presume that I don't currently have archaic beliefs, and the reason I don't presume it now is because I have beliefs. I used to have beliefs that I don't hold anymore that I now think are archaic, and I think it's possible that the same is true. Oh God.
No, I really want to know, because you don't seem to be able to change your mind on anything. I want to name one.
I used to be extremely religious. Right, I used to be.
Still are. You just replaced it with a new religion. Newsflash.
Okay. Because we're just playing words now.
How would they use trigonometry to measure the radius? Explain to me how that would be done. If you're an engineer, that shouldn't be hard for you to just think about and figure it out. Angles. You have to have 2 sides and an angle, or 3 sides, or 2 angles and a side. Which ones do they use for that?
Well, first of all, do you accept trigonometry? Because not everybody does.
Come on.
Not everybody does. It's an honest question.
No, mathematics is a legitimate tool, but it has to.
The assumptions need to be true, right?
The term measure. It wouldn't be a measurement. It would be a calculation if you have to calculate it through trigonometry. That calculation still needs to be verified as far as its validity. Because you could assume a circumference around the Earth at the equator. But if you're assuming that it's a ball instead of flat, and it's indeed flat, you're going to come up with a radius when there is none. So it's not a measurement, but you can calculate an estimation based off of presumptions, but it still has to be verified.
Right. Would it be correct for you, do you agree with the following statement? Any true assumptions fed into a calculation will always yield a true statement.
I object. It's an oxymoron to say, what did you say? True presumptions?
Yes.
It's an oxymoron. Who uses terminology like that? They're two different things, opposite things. True and assumption are 2 opposite things.
No, they're not opposite.
Basically, you're saying
you can assume something that is true, and you can assume something that is untrue.
If you guess and you guess right, you'd be able to verify it somehow. Is that kind of what you're saying?
No. I'm asking you, if I measure my height, for example, I'm 5'9", okay? If I measure my height, and then I measure, I don't know, I calculate what the length of the shadow would be if I hold a light bulb at a certain position from me, right? Does what come out of the trigonometry, is it true? Is it accurate? If my initial measurements are accurate.
You're a tiny man. It's true.
Yeah, if you can get out an actual tape measure and verify that your calculation was right, then yeah, it was correct.
No. Before you measure the shadow.
Where's the assumption? Because you have a known shadow length.
Yes. Yep. No. Listen, this is the experiment.
Listen, the angle of the shadow is dictated by the angle of the light source. This is what he's covering.
And the height of the object, right?
Yes, but it's most relative to the distance to the light source.
If I have
Charlie, Don't get in such a hurry that when other people are talking, you run them over. And the rest of us, could we please go one at a time, Charlie, please?
If the height is accurate, if my height is accurate, and the angle of the light is accurate, will the calculated shadow length always be accurate?
The unit of measure will always be accurate when it's measurable, yes. Show us your SI unit, your physical measurement.
You can measure distances in meters, and you can measure angles in radians. I don't care. It doesn't matter.
Then we'll accept your shadow angle.
The unit of measurement that you use is irrespective of the real world length, right? It doesn't matter what units you use. As long as you do all the conversions
inside the atmosphere, sure.
Hold on. I'm talking about a very simple experiment. If I tell you how tall I am, and I tell you where a light source is, you should be able to calculate the length of my shadow.
We know where it's leading, Charlie. You're trying to use something we can physically verify to prove something you cannot physically verify.
No. All I'm trying to get you to accept is that trigonometry is true. That's it.
No, I don't think anybody here said trigonometry isn't true.
Well, I'm trying to get you to say that it is true.
Yeah, I mean, I guess I gave it to you. I didn't really
say it wasn't.
I mean, I said, it's look. I said it's a useful tool, and it can get you true results. Yes, but you don't know if it's a true result unless you can actually verify it.
Sure, but you know that if the inputs you feed it and that the model that you have is accurate, then the output has to be correct.
That's why I covered what he's saying. He's referring to physical measurement.
Hold on, Lunatic.
If it's a non-physical measurement, we're going.
Lunatic, can you answer my question?
Arc minutes or any other theoretical concept, then it's not even an approximation. So,
I mean, I'm pretty much in agreement with what Battlemont. What's your question to me now?
Right, because we have an apparent position to the sun, but not an actual position to the sun. We see where it appears to be. Right? Aberration of light.
My question to you, Lunatic, is if I put you in a big room,
and
we know your height, and then Lunatic, if we put you in a room and then we know your height, and I put a light, like a lamp, right?
We already answered it.
We know the height of the lamp, and we know that the ground is flat. You should be able to calculate what the length of the shadow will be.
You know all these things. Now, when you start to blow it up to something like trying to prove Earth curvature, you're going to have to presume things that you don't know. Like
correct.
You just said, you know that the room has a flat floor, right?
Correct.
So we knew this. Now, when you're going to the Earth, we're not going to know that.
Right. But my listen. The only thing that I'm trying to draw out from you is that if there is an error, the error is in the assumptions, but it's not in the math. Like the math is math. As long as we follow the rules of math, the math.
Yeah,
the vectors, what it says it is.
It's just a mathematical object.
If we feed it bad things,
just like the question,
the math will give us bad outputs. But if we give the math good inputs, it'll give us a good output, regardless of whether or not we go and measure it later.
I think you might be confused with planar trigonometry and spherical trigonometry.
No, I'm not confused.
You've just described planar trigonometry, where the floor is level, and that is the real trigonometry that we use to determine angles. But you seem to think that the word trigonometry implies spherical.
No, trigonometry implies trigonometry. I just want you to say trigonometry is correct. That's all I want you to say right now so that I can move on to my other point.
It's correct. And so is Euclidean geometry, which is planar.
Excellent. Okay.
Do you know the difference between Euclidean and non-Euclidean?
Of course I do. Euclidean geometry, to me, is best approximated by a flat metric tensor.
Like what we experience.
No, we don't experience. Well, you're right. As humans, as everyday humans, we experience a flat metric. However, because we're intelligent and we can build systems that can make measurements that any single individual human would never be able to make, we know that is not the case.
It's just a mathematical object, though, right, Charlie?
Yeah. Well, anyway, it doesn't matter. Like,
it does. It's an abstract construct of man. So you're trying to take abstracts, add them together, and build concrete reality. I just want to point that out.
Yeah, to make predictions. Yes, that is what we do when we use math. That is literally what is going on. That is what happens when you use a stress tensor to model how strong a material is.
I know what
an abstract concept
is.
I don't think you do because you posted
capabilities. It is. It's just a mathematical construct. It could be a cube, and I can measure every vector and every stress that goes in any vector. For load-bearing capability.
What is the order of a stress tensor of a typical material? Of a real-world
material? How does it apply to your point?
I'm trying to demonstrate that you don't know what you're talking about.
I'm not letting you obfuscate from the point. I want you to bring it home because it's become redundant.
I'm trying. Okay,
you repeated to Lou the same question 3 freaking times, bro. Can you just get to
I'm answering your point that I'm taking an abstract thing and then I'm making concrete predictions from it.
We conceive that
is literally what we do.
Trigonometry, when using real world values, can be considered to be true. Yes, will be always.
What is wrong with taking an abstract concept and making predictions from it?
Is it abstract concrete?
Okay, well, we're just word salading now.
Listen,
I know we are, but I already answered this question. I said you're building out of abstracts. You're trying to put 2 abstracts together and make a concrete reality. So I've already answered this.
Jesus.
No, like it's okay to do that, but you can't, without verifying it, you can't then take that as a truth and then compile it with another assumption and keep doing that, because that's what your globe model has done. You've got these things piled one on top of the next on top of the next, and none of this stuff can be verified ever.
Yes, and there are faults to that, because if there is an error in one of the assumption ladders, it'll produce errors all around, and we do observe that. But people don't assert that all of these assumptions are known or even extremely accurate.
Michio Kaku seems to disagree with you. You know who he is, right? Of
course I do.
All right, well, he's quoted saying that in cosmology, I'm sure if you watch the chat, someone will post it, the quote right away if you want to read it verbatim. But he's on a show, too, that you could watch where he says that normally in science, if you're off by a factor of 2 or a factor of 10, that's terrible, and you have to throw it away. Okay, here we go.
Yeah, typically.
If we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120.
Yep.
That's a 1 with 120 zeros after it. It's the largest mismatch between theory and experiment in the history of science.
Yep.
You're okay with that?
Yeah, applied within the context of what he's talking about, yes, I'm okay with that.
What he's talking about?
He's talking about the cosmological constant disaster, is my assumption. Because that's the only one that I know is off by a factor of 10 to the 120.
That's a problem.
What?
It's literally called the cosmological constant problem, and you don't think it's a problem?
Yep.
I mean, it's a problem. It's not a problem with my epistemology, if that's what you're implying.
Yeah, because you're 99.9999% sure of something that is 99.999999 wrong.
First of all, the theory that makes that prediction that is off by that much has nothing to do with the shape of the Earth. That is all about quantum mechanics, which I thought you guys agreed was true.
Sorry, how are Spaceballs made? Gravity, right?
How are Spaceballs made?
Yeah, they're made with gravity, right?
Planets, moons, stars.
Oh, planets? Yeah, sure. Gravity.
Yeah, gravity. So this is illustrating the problem that gravity doesn't work, and you're saying it has nothing to do with the shape of the Earth.
No, that's not what. Yeah, the cosmological constant problem is a difference between. Hold on, you're mistaken about that. The cosmological constant problem is a difference between the predicted value of the vacuum energy that quantum field theory predicts and what we actually measure when we go out and look at the sky. That is what the cosmological constant problem is.
So, what is the problem with the quantum field theory? Is it out? Because he said it's a cosmological crisis, not a quantum field theory crisis.
Yeah. So Okay, so Albert Einstein introduced the lambda term that you see in his equations. That is the cosmological constant, and I think that's how it's being tied into gravity. So he put it in to account for a static universe, meaning a universe that, I mean, if you think about it, right? If gravity is true, then all the planets eventually should attract each other, and the universe should eventually just be like a crunched up mess, right? But that isn't what is true. So he added it in to have a universe where all the planets are basically the same distance apart from each other all the time. He called it his biggest blunder. It turns out that once we looked at the sky, we noticed that the galaxies were actually moving away from each other. And so people added that term back in. That term corresponds to vacuum energy, meaning like actual space, even when there's quote unquote nothing in it, should still have some energy in it. What's interesting about this is that quantum mechanics, and by extension quantum field theory, predicts that empty space actually does have some energy in it. So in that sense, it agrees with the theory. The problem is that when you do the calculations in quantum field theory and compare it to what we actually see, the difference is massive. Orders and orders and orders of magnitude difference.
Right, I get that. But the problem is that if energy is matter and matter is energy, and it can't be created or destroyed, only transformed, how could there be energy from nothing?
So the first law of thermodynamics, which you just quoted, the law of conservation of energy, isn't actually true.
What?
Oh, so it's not a law then.
I mean, people call it a law, but again, words are just words. It doesn't hold in all contexts.
Like in outer space, it's not true.
At
So
cosmological scale, it's not true.
sometimes words don't mean things. Sometimes they do. We could switch back and forth in a subjective reality. Like
It's true here where we're standing, but in outer space, it's not true.
So the law of conservation of energy, in fact, any conservation laws where you have like a conserved quantity, like momentum or energy, they all come from what's called symmetries. There's a symmetry in the system. In this case,
how can you have a finite amount of gases? Can you explain?
What?
How is it possible to have a finite space containing gases? What is required?
Okay.
To contain gases in a finite space.
Do you have cans of soda in your home?
No, I don't drink soda. What's your point?
Okay, but you can envision you buying like a LaCroix or whatever.
No, I'm not going to envision anything. I'm asking you.
Okay, I mean, if you can't, I'm trying to answer your question. If you're not accepting the answer, then I can't answer your question.
Sonny, you know what a can of soda is, right?
Yes, I do.
You've opened one before, right?
Yes, I have.
Okay, carry on.
Okay.
And
the amount of gas that is in your soda does not change from today to tomorrow.
Until you open it?
Because of the container, right?
Sure. Because it's pressurized.
What happens when you open it?
Sure, the gas escapes because it's pressurized and it's under higher pressure inside than the outside.
How do we measure gas pressure?
Sorry, bro. You know the claim that the fifth law of thermodynamics isn't true? Can I get you to cite the source for that?
Sure. So, do you have a physicist that you like or trust?
No. I'm asking you about how do you measure gas pressure?
Hold on, Hank Hill asked me a question. He asked me, how do I know that the first law does not in all
context? That's what I asked you, so just stick to the plot, bro. How do you measure gas pressure?
Sorry, bro. Please.
Okay, so to answer your question, Hank Hill, these are all my sources. Anyway, moving on to Sonny. How do I measure pressure? Pressure is force per unit area. There are many different ways to measure that.
What does that unit area mean? What does that mean?
It means a reference area.
Do you mean like pounds per square inch or centimeter squared per centimeter square? I mean, is that what you're talking about?
Centimeter square is a unit of area, sure.
Yeah, so how do you measure unit area?
You don't measure unit area. You measure force per unit area, which is different.
So can you measure force per unit area without a container?
Sure you can.
How?
When you step on a scale, that's what you're doing.
Oh my God!
There is a force distributed,
bro. Not talking about stepping on a fucking scale.
Okay, then ask your question precisely.
Gas pressure without a container. Show it now.
Show you a gas pressure without a container?
Yeah, demonstration of this.
I can't.
Okay, so
you need a container.
Does anyone else need any more of this globe doctrine? Because I'm kind of tired of it. You want to continue talking to him, it's fine, but he's just a religious tard, man. Literally.
No, well, he's just said exactly the fundamental point that you can't have that pressure without the container, right?
Yep.
I mean, are you just going to mute me every time I say something that threatens your worldview?
You're not threatening my worldview. You know what? Reality is on my side. I don't have anything to worry about.
So the whole point about the gas pressure, the whole point about the gas pressure and container thing is, my point is that the gravity is acting as the container.
Incorrect. Because you can demonstrate how simple that doesn't work by creating a slight low pressure in your lungs, and you can actually suck air up and away from the ground when breathing in. Or if you use a straw and you create a slight low pressure in your mouth, you can actually suck fluids up, out, vertical, so meaning away from the gravity attraction of the earth. And that's a slight pressure difference in your mouth. So if gravity was said to be this container, firstly, you're talking about a Newtonian type of gravity, something pulling towards a center. And in that Newtonian model, it's distance dependent. So you would have the strongest gravity toward the center. And as you get further away from that point, the gravity would weaken. So if I can pull water away with a slight low pressure in my mouth at ground level where the gravity would be strongest, then any moisture or air in the atmosphere would start to fill the available volume that it has available to it. It's not about a sucking, it's about gas moving to fill the available volume, so we can then calculate the pressure inside the container.
I agree, and that's why the atmosphere goes so high up in the air, because gravity needs a lot more distance to act as a container.
Ridiculous.
No, but you understand, you cannot have the gas pressure without the container. And you acknowledge this at least twice.
Right. I mean, I think the disagreement here is that you're not accepting my statement that
it's that you need a physical container to contain gases.
The gases don't care whether or not it's physical. They care about a force.
Listen, you're out of your league here, man. You're completely out of it.
So is that force stronger? Is that force stronger at ground level or up in the sky where you magically think it becomes a container? Why is it not containing at various levels closer towards where the gravitational attraction would be stronger?
I mean, the pressure is greater closer to the center. My whole point is that
the pressure is.
Sorry, I'm sorry.
No, you go, Sonny.
And what about water vapor?
What about it?
Yeah, it goes up.
All gases expand to fill the available volume of their container. And if there is an infinite container, then you would have almost zero gas pressure everywhere. That's including on Earth, on all the stars and all the planets everywhere, because if space is this homogeneous substance and it's at such an incredible low pressure, everything wants to always equilibrate. And like I've explained, the gravitational attraction would be the strongest at the ground, and it wouldn't suddenly become a container where the air particles would actually be so thinned and refined, because you agree that the pressure's greater at the surface. and then goes up, getting exponentially less. So at that point where it's exponentially less,
there's not a point.
The particles are so far spread out per cubic feet that the pressure is almost to zero. It's 0, and then some decimal places. At that point, you think somehow the gas can contain gas.
It's not a point. It's a gradient. I actually didn't know that it was exponentially decreasing. Although I guess that would make sense.
Have you heard of the Kármán line? Have you heard of the Kármán line?
Of the what?
Kármán line. I guess that was the answer to my question.
Common light?
Kármán line. The Kármán line.
The supposed line where space begins, which you were saying wasn't a point, that it's a gradient. But we have this said fictitious dotted line that we place in the middle of air, and we call that the Kármán line. And it's the fictitious boundary where supposedly space begins. Now, due to ionospheric bouncing, we know that we're definitely bouncing a signal off of something physical, because signals don't bounce off of air. So the signal travels all the way through the denser air, and then at some point where the air particles are so sparse, the signal turns 180 degrees and travels back down to the earth. That only occurs on a physical, tangible container, which must be there for us to have gas pressure here in the first place. Otherwise, the gas pressure here would equilibrate with the environment there to find its equilibrium.
Hold on. So you don't think electromagnetic signals bounce off of gases?
You think they do?
Yes, they do. Or at least they can. Like, there's nothing about a gas that says they can't. They can do a bunch of sort of things.
Can you provide any citation of any signal ever being bounced off of air? And I'm not talking about in a chamber where you've significantly ionized a certain particle field and you can create some kind of warped reality where you can assume that it can almost represent something physical, but not really, because you've excited the molecule.
So you agree that under certain conditions you can bounce it off of a gas? Not necessarily air, maybe, right? But a gas, it's possible. Yeah?
Out of potentially certain ionized gases that are at pressure, yes. At the low pressure where that zone is, no.
What do you think is the cause for a light beam or an EM beam being reflected? Like, what is the underlying mechanism?
All of them are line of sight, and it's off of a physical object. Same with radar, same with sonar. It has to bounce off of a physical object and return back to the receiver.
Okay, so I understand what you mean by physical in everyday life, right? But can we get a little bit more precise?
Why would sonar be there if the signal bounced off air?
Okay. Is water a physical object?
Can you answer my question? Why would sonar be used to find physical, tangible objects if signals bounced off air?
So the signals definitely bounce off water.
Wouldn't you get a misleading signal if you could bounce signals off air?
Under certain conditions, you can definitely bounce signals off of gases.
Off of really compressed, pressurized, ionized gases in a chamber, yes, you create certain conditions.
Yeah. But ideal gases, that's the word you're looking for.
Thanks.
Ideal. Do ideal gases exist in the atmosphere becomes the next question.
Yeah, and at that altitude, where the particles are so spread out that they're almost not colliding. That's why the temperature drops so significantly. There's almost no pressure. So there is just more nothingness between very sparse molecules. So the signal bounced through all the densely packed air molecules down by the surface without reflecting. But as soon as they reach a zone where the particles are less densely packed together, it suddenly turns around and goes back.
Mm-hmm. Yeah, because are you familiar with the ionosphere?
Mm-hmm.
Do you know what cosmic rays are?
It's ionized.
I mean, do you deny its existence?
Electrically charged. I didn't hear anybody deny anything.
Which is why I'm asking. Do you I'm not assuming.
You asked to it. You're trying to infer something. Nobody did. What?
Yes, and I inferred it, and I'm double checking by asking BattleMod. Okay.
That's what we've been discussing. Ionospheric bounds.
Ion what? Skywave propagation.
Okay, so flat Earth solar. Do you agree that the ionosphere is there, or do you disagree that it exists?
How did that can be spherical?
Okay, who cares what shape it is? It could be. Let's assume the Earth is flat for a second.
No, who is saying that? What are you saying now? That it's ionosphere, it's spherical. How we do know that?
Oh God, this shape does not matter for this. Do you flat Earth solar? Do you agree that there is a layer? Who cares what the shape is?
Do you remember what we've just been discussing? Do you remember what we've just been discussing? That they do bounce signals off of this region where your molecules are meant to be so sparse and the pressure so low. And the only way that signals really bounce off of objects is if it's an object. And it can return that signal back to its origin point without scattering it.
There are plenty of non-solid objects that you can bounce off signals off.
You can also travel through some solid objects.
Really?
Yes.
Like what?
Electromagnetic waves. You're saying that does your Wi-Fi work in your house?
Yeah, you're right.
There's an absorption rate and a reflection rate for every. It depends on wavelength strength and intensity.
You are absolutely correct.
And the ionosphere is full of ionized particles. Yes, they attach to gas particles, but they're also physical particles.
But sparse. So one particle per so many cubic kilometers. Yep. So if they are ionized, great. But you've got, imagine a visual with 100 little balls packed in a little cube versus a cube with one ball in it. And you're telling me you can bounce your signal off one ionized ball.
The ionosphere does not have one particle per cubic kilometer. You're just wrong about that. It's much larger than that.
Higher, you mean?
Higher, yes. You know what I meant.
I do, Charlie. That's why I helped you out.
I'm just glad you conceded on the fact that you need a container to have gas pressure and that you were quite adamant about it. Yeah, great. That's why I say I'm really excited that you conceded on that. And maybe later on, it'll dawn on you that we're breathing pressurized gas, and container has to be something physical, like an open container that I can hold water in, or a closed container that I can hold gas in.
So, are you familiar with sulfur hexafluoride?
Yeah. Can I say something before you guys continue? When I came back, I was pleasantly pleased that you picked Flat Earth Solar to talk to. You know why? Because it seems you're a decent kid, man, or a decent guy. I don't care what others think. A lot of us here are passionate and assholes. But you picked the right guy to have a normal, civil conversation with. And I appreciate the fact that everybody else is letting you guys do it. So cheers to everyone.
Thank you.
Yeah, thanks.
Get fucked.
So, I agree that it needs a container, right? But it totally depends on what your definition of container is. And I think in order to get away from semantic arguments like that, we should really look at, okay, what is the job that the so-called container is actually doing, right? And to me, it would seem that job is applying a force so as to keep particles within a certain volume. Yeah? And gravity does the same job. So
That's a peculiar way to describe how your cup would hold water. But you're welcome to try and do mental gymnastics to make the concept of a container become ambiguous.
Okay, great. Then you describe to me.
Or my definition. What you're describing is an explanation. Then everyone will have different explanations based on their language, based on subtext, based on semantics. Everyone will have a different explanation. And that's why there's this little important thing called a definition. And then when you look at the definition, for a container, you will see it is usually a physical substance. And if you're going to hold pressurized gas, it's certainly not mediocre in its containment strength. It's usually a really hardcore steel. And your sodium hexafluoride that you were going to describe to me would be brought to the demonstration in a sealed container. Then you'd pour it probably into, let me guess, you're thinking of a fish tank, right? So you probably pour sodium hexafluoride into an open glass container called a fish tank, which is capable of holding liquids. And then because sodium hexafluoride is more dense, it's going to settle. And you're going to be able to drop objects into this terrarium or fish tank filled with a more dense gas, showing you exactly that the object you dropped is not attracted to the earth because of gravitation, and that it's actually a density relationship to what surrounds it that's either going to cause a downward vector or a floating or an upward vector. So you're going to demonstrate a density relationship using a sealed container.
Why up or down? Why not sideways?
And a more dense gas.
Why up or down? Why not sideways?
What did I miss about what you were going to tell me about sodium hexafluoride?
Why up or down? Why not sideways?
You took
gases move in all directions. Gases move in all directions. There's
right, but when you have a density tower, right, they organize in the up or down direction.
Why not sideways? Have you ever seen anything fall sideways?
Yeah, I wanted to cover that. And the density tower is contained in a manner where there's only up and down.
Okay, hold on. So if you can create a density tower with gases, right?
Displacement. So there can be sideways movement in the density tower due to displacement. So, I mean, you're just technically wrong about that.
Right. I'm asking why don't they separate sideways as opposed to why do they separate up or down?
They can. As a denser object tries to rise and a less dense tries to fall, they can be parted and go side to side.
Right, but that's only momentarily. In equilibrium, they will settle vertically. Like if you wait long enough.
There's still 4 vectors. Up, down, and side to side.
But hold on, I want to come back to a specific point about sulfur hexafluoride. If you have sulfur hexafluoride and you interface it with, I don't know, air or another gas, it doesn't really matter, right? They're vertical to each other, and there is something that's keeping the gas below and another gas above. In a similar manner,
only for a period of time.
Okay, so in a similar manner, you can have water in like a glass, right? So can you explain to me the micro description of what happens when a water molecule is heading towards the edge of a glass? How does the glass stop it from going through the glass?
How did we get from discussing gases and closed containers to water droplets?
Because they're both fluids.
On the inside of a container.
Metaphysics.
They behave like fluids.
It isn't always contained. Listen, if we're talking about a glass, it isn't always contained. It can pass through the glass due to condensation and differentials in temperature.
You're mistaken about that. Condensation does not get the liquid outside of it. That's not what condensation is. Condensation happens when the gas outside is cooled enough for it to condense. But anyway, my question...
Are we talking about liquids or gases? Yeah,
well, right now I'm talking... The question I want to focus on, and I can go back to the sulfur hexafluoride thing just fine.
Every
time you speak, you make like 10 points. So I like to stick to one at a time.
What does the ideal gas have in common with our atmosphere? That's the problem I have with everybody who always goes to hexafluoride.
Battlemon.
It doesn't exist in nature.
Battlemon. So if you have a glass of water, okay, and I'm tracing a molecule of water, okay, it's bouncing around, and then it's heading towards the wall of the glass container. What happens such that it doesn't go through the glass container?
Oh my gosh.
He's trying to grandstand. Give him a break.
I mean, I can tell you what I think happens.
Surface tension. What?
But it seems like you just don't accept my explanation.
It's here. That's great. That's great.
Well, you're going to say what? The attraction of the water to the water keeps it contained?
No. It doesn't.
The physicality of the glass.
It's not the physicality of the glass. The glass. Jesus.
Glass. The density.
No. It's that the glass has protons and electrons, and that the water molecules also has protons and electrons. But in particular, the electrons are really what do the most work, right?
Fantastic.
The electrons in the water molecule repel the electrons in the glass molecules, right?
No.
And you accept electromagnetism, right? There is a repelling force between like charges.
Do you believe in math, you guys? Do you believe in math?
Hold on. Do you not believe that like charges repel?
Do you not believe it?
Do you not accept it?
Do you know how many times you said believe? And you were telling us that you gave up religion.
Do you accept that like charges repel?
Just go back to believe, man. That's more honest.
Yeah. We know where you are.
Relevance?
Okay, because I'm trying to explain to you that what a container ultimately does is just apply a force to the gas such that it remains within a certain volume. That's all a container is. And so if you can accept that description of it, I can show you how a glass with water in it does exactly that.
Gas pressure is the energy or force exerted on the walls of a container. How do you have the gas pressure without a container, man? Stop playing stupid games. You sound dumb.
Witsit, how do water molecules get contained in a glass container? I have a water molecule. It's traveling towards the edge of the container. What does the container do to keep the water molecule inside of it?
It's a physical barrier. It's a physical barrier, so it contains.
No, that's not what happens. It's not a physical barrier, so it contains.
Well, so what's it? This guy's already acknowledged 3 times that you can't have gas pressure without a container, and he's agreed emphatically. But yet he thinks the container is just gravity and some outer layer of molecules, which are the less dense.
Flat Earth Solar. What do you think happens when 2 water molecules collide?
How
do you think they're like 2 marbles that click and like 2 billiard balls?
Stop! You sound dumb. If I let gas out at the surface level where gravity supposedly is strong because it goes in all directions, how is this?
Okay, you're just reciting something. Can you answer my question?
Listen, because it's stupid.
It's not stupid. It's a great question to ask. What happens when 2 water molecules hit each other?
It's a state of matter. Well, they combine. It's not really water until 2 molecules combine.
You think 2 molecules of water combine?
Water and gases don't really.
No, not that they combine one to the other.
Okay, fine. Let's switch to gases. I guess we can't talk about fluids in general. So
you should understand. Okay, so when you
have 2 molecules of water, okay, they come close and they collide and then they grow apart. What is that collision? Hold on. The collision. What is actually going on under the hood when I say they collide? My understanding is the electrons. Hold on. My understanding is the electrons on the electrons on the water molecules repel because like charges repel, and there are a lot more electrons than protons, right? And so they have this repelling force, and when they get really close to each other, that repelling force is extremely large, and so they fly apart.
Listen, hold on. Solids contain liquids and gases just because of the one is loosely bound and the other is more closely bound at the molecular level. So a solid is tighter in molecular structure than a liquid. It can't flow through it.
You're right.
I mean, it's a dumbass question.
No, it's not a dumbass question.
Absolutely, it does when we're talking about Earth in the atmosphere and containment of the gases.
All right, Battlemont.
So
what happens?
So in an open system, gas is free to move omnidirectional. Is it not?
All right, sorry, I have to go. My wife is here, but I'll come back.
Oh,
Yeah.
that's cool, Charlie.
That's
I'll talk to you guys later. Bye.
questionable.
I'll reset your name for you.
He can't let his wife catch him talking to flat earthers. She just pulled him in the
That's
driveway.
highly-
He's like, shit, I gotta go.
Highly sus. Sounds like he's about 19 or something.
I know. 29 with a master's degree, but I gotta ask why solids contain liquids.
I could have
Go sideways.
The wife gets home. Who the hell are you talking to? You know, like, oh, a bunch of flat earthers. No. I think it probably happens a lot to these guys.
He would never tell her the truth, but yet he spends hours on here, whoever the hell he is.
I want to tell Witsit good job for dealing with the good Gestapo last night.
Yeah, exactly. Yeah, no.
Thanks, I guess.
Yeah, dude. I was watching the whole time. I'm like, they remind me like the DNR, the park rangers, right? They've got a federal jurisdiction, like so. They can give you a ticket anywhere in the United States. Those guys tend to have a bigger chip on their shoulder.
Yeah.
The younger dude was the superior officer, right? So, and he obviously had a chip on his shoulder, and you were poking at him. The other guy, I think you were right.